Professor B.L. Siri. I'm very honored to be invited at this conference. I have to say I never enjoyed such a colorful ceremony like here. It was really perfect. I'm impressed by the number of people who came here and are interested in these important issues we are going to discuss. And I was not only honored, but I enjoyed to be invited because during the last 10 years, I think, I haven't been in Sri Lanka. But before this, I have been here quite frequently, as Professor B.L. Siri said, for several research projects, and it was always an enormous pleasure to cooperate with my Sri Lankan partners. So I really liked and loved to work here. I enjoyed the country. So thank you very much, the committee and the distinguished guests for this invitation. So I choose the title, Roads to Transdisciplinarity, in order to indicate the long and often very cumbersome road we have to go in direction to develop sustainable management concepts. It's full of many steps have to be taken, and it's full of hurdles which have to be overcome. Please, the next. So my talk will first record a general framework of sustainable resource management and the multiple challenge for science in this respect. And I think it was already said today, it's enormously important that the sustainable management is built on a good scientific basis. I will then try to bring some examples, my own experiences, some from here in Sri Lanka and some from Europe. And from my experience, try to derive some guidelines, how we can proceed, what we should do next, where we should go. Thank you. So essentially, sustainable management means harmonization between three different fields. It's the sociology in its diverse forms and formats, it's economy, and it's the environment. We have to bring things together in an integrated form on a scientific basis. I think I better go down because otherwise I don't see my slides well enough. So one of the main aspects one has to conceive or consider is the ecosystem functions, which are useful and used for humans, the so-called ecosystem, ecological goods and services. And as this graph, I think, points out, is again you have to consider the ecosystem processes, the functions that rely on, and you have to understand the sociology and socio-economy. There are various, a diverse range of ecosystem services to be taken in consideration. It can be professional services, for example, with regard to clean water, to fisheries, to transport facilities. There are regulating services which are enormously important, for example, with us in Europe, where we had enormous floods and flood catastrophes over the last year, so it's flood control. It's the self-purification of the ecosystem, and then, of course, not to forget, it's cultural services, the landscape, aesthetics, the value for recreation, for tourism, and so on. So when one pursues these aspects and when one gets involved in these aspects, you are generally have three major groups of players. The authorities responsible for the control, it's stakeholders of quite diverse interest and partially controversial interest, and of course there is the science. And the science is an arena because it's again diverse, it's manifold, there are different scientific approaches which need to be coordinated, and then there is the policy arena, where the interests are expressed and the stakeholder interests, as I said, are partially controversial, so they have to be harmonized. And this essentially, together with authorities in policy, is what we could call the policy arena. So please the next. The role of science is manifold. There is a huge range of things which have to be done. The main thing is to understand the functioning of the environmental resource base. The second main thing, similarly important, but equally important, is the social ecological science interface. We call it SES, science, social ecological sciences. Then there is a new discipline developing, it's transdisciplinary or translational research, as it's often called now, interested in the transfer of your new knowledge, the creation of new knowledge, as Professor Dissenaika called it. You have to, how to transfer it into the political arena, how to transfer it and make it applicable. So that's an important step, and essentially I think a lot of this meeting today is also interested in this aspect. And then, sorry, no, I have one more word to say, bring it back, thank you. This is sort of, the first 3 points are more or less academic. You can stick in at your university and try to write intelligent papers which nobody reads, which is little read. But the important thing in sustainable management development is a dialogue between scientists and practitioners. And this dialogue has to be led with stakeholders, with authorities, and with decision makers. Thank you. Thanks. So I just want to, with this simple graph, is that we have essentially in science to move from multidisciplinarity, where the individual subject areas like physics, ecology, humanity, sociology, independent, they are considered independently. Of course, they are needed, but they are considered independently. That's what we could call multidisciplinarity. What we really have to reach, the step to reach, is get this more interdisciplinarity, where you start off with a high order concept and a way to integrate the research findings. I will come to this later. The next, please. So in a recent article, Crossing Boundaries, Complex System, Transdisciplinarity and Applied Impact Agenda, David Simon and myself have outlined, on the basis of research we have done to a large extent here in Sri Lanka, actually the requirements and the hurdles to overcome. So it's a very simple scheme, identifying the various aspects, the various fields which have to be addressed. Essentially, basically, the aquatic system in its holistic context, in a catchment context. This offers the services. It is used by the social system and decided upon in a policy arena, so to say, in simple words. And the horizontal bars here indicate the problems we face as scientists to really derive the right knowledge. So it's already a problem to have an interdisciplinary approach among natural sciences, for example, ecology and hydrology, that separate fields, they have a separate training, they have a separate conceptual understanding. And it's even more formidable when, and we encountered this in some of the programs I was involved, to connect with the social system and to find the bridging research questions, identify them and work alongside. And then sort of the largest hurdle to enter this policy, science policy dialogue, to get involved in this science policy dialogue. So, next please, this is a little bit gray theory, but it sort of outlines the framework. I would like to put now some meat on this skeleton by bringing some of my own experiences. And these experience and involvement in management issues date all back 35 years. They are of vastly different nature. Professor Biasiri already had said some of them were in Southeast Asia, somewhere in Europe. And I have to explain how it came that we did work in Sri Lanka. Actually, the lean knowledge in Austria, several institutes who cooperate very well, defined to make a postgraduate training course for limnology. And this runs now 40 years. When I'm back, there will be the anniversary. And several people from Sri Lanka, Professor Ivan Silberg, for example, was there in the very early days, and many others. What we did with these students, postgraduates, not students, postgraduates, we informed them about limnology. Our teaching was based on the limnology of the temperate zone, and with little applied aspects. So I thought this cannot be the best way to do it. We have to gain experience of the tropical problems and the tropical ecosystems. And so we started to conceive a program in Sri Lanka for various reasons, and came here from 79 to 1982. And the scope was to understand the resource base of these systems under the multiple human pressures, and you know better than myself what very hard pressures on this reservoir system, irrigation, water abstraction, fisheries, and the rest of it. So we carried out this work. It was a cooperative effort. It involved scientists from Europe and scientists from Sri Lanka. And this photograph here nicely shows these three men in a boat, so to say. One of these men is a woman, is the late Professor Annie Duncan from London University, who played a major role in this. Then myself in young years, and also Professor Silva in his earlier days. So it was a cooperative effort. Our scientific orientation was, we were ecosystem orientated. This was the time when there was an important international program, the International Biological Program, focusing on inter-system interactions, and essentially we applied this, but then we had another focus, which was fish ecology and fisheries utilization. The next, please. So this is the complex working plan. We started off with this from a paper in 1981, so long time back. just to demonstrate, I'm not going into details here, of course, but just to demonstrate the main interactions we had to conceive, meteorological interaction, the interaction by irrigation and so on. But our main focus was the limnology, water quality aspects, the control of the trophic state, and the fish population. Next, please. And this is one of the interesting findings, just one I picked is what we discovered in these reservoirs, that there are enormous quantities of small-sized species, which nobody believed at this time. I remember when Professor Sena de Silva with Austria came there and we showed him our first results. He was too busy because he had just inherited a professorship at Ruhr University. They said, that cannot be, so to say. Actually, you have it in all the reservoirs. There's an enormous concentration of fish, and only a very, very small part which is exploited. So you have a high fisheries potential and a lot of so-called untapped resources. The next. But altogether, it was just sort of to show that we not only spoke, but we also did some work. When I analyze our approach with regard to the necessities for developing management concepts, sustainable management concepts, I have to say it was just sort of an academic study on an ecosystem. It demonstrated, and this is very important, the relevance and the significance for management issues. However, we were not involved in socio-economical studies. We didn't derive management concepts, and we had relatively little to no discussion and dialogues with the practitioners. There's only one funny thing which I always remember. When we came there with the whole crowd in '79, we went to the Minister of Fisheries in the department because we used the institute at Jayewardenepura and the facilities there, and explained him our working plan, and then one of his secretaries said, "Okay, sir, when can we have your results?" And I said, of course, we try to be as fast as possible. You can have them soon. But of course, not he, not we understood how complex it is to bring the creation of knowledge into the praxis. So this is and it's still only partially there. So it's a major thing. If I'm too long, Swan, you give me a kick to fast now. Okay, the next. So, but it was good to demonstrate the significance of this approach. So, 15 years later, we conceived a larger size and more management-orientated academic concept, the so-called fish concept, which then ran between, the fieldwork ran between 1980 to 2003, financed by the European Commission. It had a long, winded title, Strategies for Partitioning, Productivity, Capture Fisheries, Social Benefit, Local Markets without negative environmental impact. So it has it all what you think when you think about sustainable management. The next, please. The scope was international. So we had, I think, 4 or 5 European partnerships there. from the UK, from Austria, from France, from the Netherlands, maybe it was from before. And of course we had the local partners with Sri Lanka, with Thailand, and with the Philippines. It was multidisciplinary. We addressed the aquatic ecosystem, we addressed the fisheries, and we addressed the socio-economics of the riparian population. So again, in terms of a really comprehensive understanding of sustainability for a landscape, it was a slice of the cake, but of course an important one. That's quite clear. The important thing was we conceive the reservoirs as integral part of the catchments. It had a comparative framework. We compared 3 catchments and 3 reservoirs in Sri Lanka, Minaria, Victoria, Uddavallave, 1 huge reservoir in Thailand, and a very huge, deep natural lake on the Philippines. And it had a long time frame. So actually we started discussing the issues maybe mid-90s, and until the papers were written was 2008 or 2009. And we're still in contact, and as the paper of Simon and Schiemer shows, which it just was published recently. So it's, the information is still in our mind, and we have to use it. Next, please. So this is the original working plan, and this is interesting. It shows the various phases, so the project planning, partnership meetings, method trainings, preparing the instrumentation, and so on, took quite a long time. We had an interesting meeting at the IFS in Kandy, which I recall with great pleasure because it was scientifically quite rewarding, where we brought all the groups together, tried to integrate their perspectives, and you can consider, or you have to consider that this multidisciplinarity was overlaid by an enormous diversity of research traditions from the various fields and also from the various research cultures in Europe, in Asia. But then, in second phase, and I show this as an example where one has to improve the things. We worked in work packages, 4 tasks: limnology, fish fishery, socioeconomics, and aquaculture. And the concept was that at the end, in phase 3, there should be a joint data integration, data analysis, and modeling. So these 5 or 4 arrows here show sort of the main road. And this again has to be improved. There has to be throughout the phase 2. There should have been, it was actually de facto, we had it, but we developed it on the way by going. There should be a direct integration throughout the period. Next, please. So, one of the key issues, the key environmental issues in sustainable management, sort of where what you have to control is, of course, the quality of the water. Water is a central issue, so it's the control of the trophic state of these reservoirs. See that there is no danger of hypertrophication, no danger of toxic algae production, no deoxygenation, and so on. So there's one issue of the many before the next. And this, maybe the insert on the side shows the top-down controls, bottom-up controls and top-down controls, which involve the complex social system. So in terms of sustainable development, you have to take these interlinks throughout your research phase into account when you really want to develop a management, sustainable management model. The next. So things were published in a book, and I hope it's well distributed here in Sri Lanka. It's an aquatic ecosystem and development. It was an enormous effort to bring together the research data from maybe 50 people who were involved in this program. It was published. By the way, I have one more copy which I brought with me, and somebody has to tell me whom I should to which university I should give it. Next, please. So when we think on achievement, learnings, but also shortcomings, we have to say we were on the right track for sustainable management. We had a catchment approach. We had stakeholder identification, and we worked with them. There were a lot of discussions with them. The shortcomings, so we were on the right track, but of course we didn't achieve an impact, an immediate impact, because we had restricted, we had a user meeting at the end of the program, meeting the politicians and the practitioners, and this is again too late when you have to involve them throughout the time, but I come back to this later. We were not involved in co-management, and we had no continued science policy data. So the next one. So, in Europe, more or less starting, then it is good, please bring the next one. Starting at the same time, you can skip the next, thanks. Starting at more or less 30 years ago, we were involved in the management of large river floodplain systems, especially on the example of the Danube, which flows near the university, so it was quite clear you have, it would be good to work here. There was in 83, 84 actually, a major discussion on a hydropower dam to be built in these enormous floodplains downstream of Vienna, and the scientists, we were asked to give our opinion and do some research on this, but then the politician decided to build the hydropower dam against our warnings. So there was an enormous political uproar, or public uproar against this, an enormous movement which essentially changed the Austrian policy, made it much more, it made it greener than it was before. And so the plan then was stopped because there were 2,000 people who camped in this alluvial floodplain zone. Peaceful camping, but yeah, it was impressive enough. And at the same time, there were 30,000 people on the road in Vienna demonstrating against the hydropower. So this is just the beginning of my involvement, because then there was an ecology commission set up by the government. They said, okay, if you know better, you come up with management plans. And in these ecology commissions, there were the socio-economists, the authorities and scientists of all fields were involved. And you can imagine, or maybe not, how long it takes to have maybe hundreds of people involved to come to a common opinion, if any. But the good thing from this ecology commission was we learned to understand each other, the necessities, the way of thinking. So there was a good start of a continued involvement in management. And since then, I have been involved in many forms in this science practitioners panel. Next, please. 10 more minutes. So I perhaps jump over this. Large rivers are important elements. They offer a lot of goods and services. Many of these functions relate to the connectivity of the water bodies to their wetlands and to their floodplains. The next. And of course, there are many users. There are many stakeholders. It's water supply, important aspect, flood mitigation, conservation, recreation, navigation plays a major role, hydropower production. And it's quite obvious that all these stakeholders have diverse interests, which are in many cases sort of controversial, not fitting well together. Next. And one of the key features I explained already with the Asian example. The key feature is to control the trophic situation of your water body. In the case of large rivers, the key feature is the geomorphological dynamics. This is shown nicely here by well-worked up historical development of Danube landscape. The interesting thing is it is dynamic, it's completely changing, but it maintains always the same sort of composition of habitats. And so dynamics is the way to maintain a certain quality, which is the important thing which one has to conceive here. The next, please. And that's also an important issue. You have to follow, for management, you have to follow the cause-effect chains, which can be demonstrated here nicely. It's the key processes, which is hydrology and geomorphological dynamics, which leads to a certain landscape composition, and this is the arena where the ecology, the ecological services are produced and take place, including the biotic diversity. So in order to manage, you have to screw at the key process level, so to say. The next. I will fasten up a little bit. So of course there were a lot of human alterations, ongoing alterations, which next. Next, please. Which lead to ecological deficiencies in this landscape. This is the groundwater table is reduced. There is an incision of the waterbed, groundwater table is reduced, and the more the greenish in 1970 shows the better floodplains with better original ecological function, and the prognosis what will be in 2020. It becomes drier, groundwater is going to be lowered, and so on. There are a lot of ecological consequences, which I have no time to go into next. So there has been requests from various stakeholders for remediation, management, sustainable management, by improving the status quo and maintaining the status quo. And this is, of course, important for nature conservation. This whole stretch has been declared a national park. But it is also important for navigation, because navigation requires a safe route, especially at low water conditions. And as this caricature tries to indicate, of course there is an enormous danger or the fear from the part of view of the ecologists and conservationists for that navigation, measures for navigation destroy the situation. Navigation is of high political power, so stakeholders have different political power which have to be conceived. And so there was conservation who asked for remediation programs and also the navigation. Next, please. So the government again decided to discuss an integrated river engineering program where the controversial interests of navigation, ecology and conservation should be taken into consideration. And this is, I think, quite the concept of the government is insightful, and it has long-term consequences, and actually that's one of the conclusions I will draw. In order to resolve the controversy, they installed an executive board, the executive board, which had a clear mandate also of deciding, and this executive board consisted of authorities, scientists and stakeholders. And since it's a complex issue, what you can do by improving the situation, we needed a planning team of civil engineers, plus ecology consultants. And this whole discussion, which took several years, and actually it's a process which still continues, has to take into account public participation. Otherwise, at least in our case, in Germany and Austria, you can run against the wall when you don't inform the public at the right time what you want to do and why you want to do it. Next. So, it was a long and winding road. Up to now, it's the title of a chapter, a title of a publication which I just tried to do this, to explain this. We had 3 years discussion in the executive board to come up with joint planning principles which took into account the conservation issues and the navigation issues. There have been several scenarios which had to be benchmarked ecologically, and we then came up with something which a compromise. You can call it win-win situation, but essentially it was a compromise. But anyhow, because of this executive board, we forced much more ecology, much more sustainability into this decision. Otherwise, the ministry, of course, could say, okay, we have the money, and we just go along the interests of navigation. Next. Okay, few conclusions. There are several things which we have to take into consideration. One is sort of the science part, functioning of the resource system. The significance to move from multidisciplinarity to interdisciplinarity. The question of transdisciplinarity research. The significance to get impact, to connect science to the policy arena. And finally, I just try to outline an operational procedure which one could apply to solve the situation. Next, please. So one of the major challenges for science is to, both in social science, natural science, to apply an analytical procedure to understand cause and effects. What you have to understand, what are the main problems, when you make a change, what does it mean? What is the effect? So you have to put this in an analytical procedure. So since you are involved in very complex system, many step systems, of course, this is not easily to achieve, but it has to be the backbone of our approach. And it's simpler, of course, I think it was said by Professor Dissanayake, when you deal with natural science, when you deal with physical aspects, than with social aspects. But even in social aspects, you have to try to combine analytical approaches and combine the analytical research findings. You have to understand the system in terms of resilience, how resilient it is against, for example, global change, or how adaptive it is, how in which way it gets transformed. And the other main message is you have to be analytical, but combine this analytical approach with a holistic approach. Not forget that there is a complex system which has to be conceived. But in order to find good answers for management, you have to apply this analytical approach. The next. Now, we spoke about multidisciplinarity, interdisciplinarity. And again, what one finds is interdisciplinarity is the more important approach. And how can it be defined? It has to be defined by a joint problem identification, for example, between environmentalists and sociologists in their research work. There has to be the hypothesis should be jointly defined, and again, extremely important, one of the mistakes, so to say, we made during the Fischstadt project, not really, but essentially, there should be an interaction throughout the whole research program. And so this science has to sort of integrate much more strongly and do this around the world. We are not educated in this form. We are educated in our disciplines, and there is an enormous resilience to leave the framework of your discipline, to leave the framework of your box. It's like I have the feeling, I'm not going to explain this one, it's like with a rubber band. If you move out, there is an enormous elastic band which throws you back to your own disciplines. But we have to overcome this, and in order to overcome this, meetings like this are enormously important. And I really congratulate people who organize this. And I think you need new educational curricula where this interdisciplinarity is approached in the curriculum. Next. Transdisciplinarity research, booming research to transfer, finding ways to transfer scientific knowledge into management processes. The next one. It's a booming research. The next, please. There is a lot of new journals when you look when you Google the journal. There's enormous amount of new journals in this sustainable management issues. Enormous amount of papers written, but no really solidified or consolidated framework. That's one of its characteristics for new science. I think we are on the right way. Next. So important. All this is academic, and important. It's important in order if you really want to get influential and effective, you have, as a scientist, to try to go into this science practitioner dialogue. And this requires that expert panels should be set up, in that there is a continued science practitioner dialogue, and experts should be part of the decision processes, which also means that you probably have to change. I don't know how the Sri Lankan situation is at the moment. In Europe, we have these sort of general legal frameworks which make it easier, but this is very important. So finally, final slide, next one. What have I learned to approach this problem? I think important are expert panels with long-term mandates. They are managing boards. The expert panels have to sort of define the way a program should go. The management boards, including stakeholders, scientists, authorities, should have a decisive power. It's important to have long-term, comprehensive plans, including all the stakeholder interests, to be long-term involved in this issue, and to be involved in adaptive co-management, where you really try to apply your sustainable management concept into practice. Of course, one has to be adaptive because we have to learn on the way and the rest of it. So, to finish up, I would like to say that from my personal point of view, I found it extremely interesting to be involved. It is also rewarding because along this involvement, enormous amount of new scientific information is created. So it's sort of a creator of new information, and I think we are on a good way. For example, with meetings like this, but definitely we are far from reaching a goal. When you compare it with a marathon run, we may be at kilometer 5 from the 42 point, I don't know, 4 what it is. So, but we are on a good way, and I think it's a rewarding, interesting, challenging approach. I thank you very much.